Welcome to our YouTube channel, Nursing Insight with Caleb Mlonga. So this is our very first YouTube video that we're uploading to our channel. Stay tuned and learn more. So our lesson for today is the pathophysiology of hypertension. So before we go into the pathophysiology, let's just look at the background. So hypertension is a cardiovascular condition in which there is sustained elevation of systolic blood pressure of above 140 millimeters of mercury and a systolic blood pressure of over 90 millimeters of mercury. So in blood pressure, we have terms that are common, such as blood pressure and cardiac output. Blood pressure is a product of cardiac output multiplied by peripheral resistance. So this means that blood pressure is as a result of the amount of blood that is produced by the heart and the resistance that it meets in the blood vessel, which is how narrow or wide the blood vessel is. So the second one is cardiac output. Cardiac output is a product of heart rate multiplied by the stroke volume. So cardiac output is basically the amount of blood that the heart is producing. Yes. So having that background, now we can move into more details about the pathophysiology of hypertension. So in normal circulation, pressure is transferred from the heart muscles to the blood each time the heart contracts. And then pressure is exerted by the blood as it flows through the blood vessels. So here, the pressure is generated from the heart muscles, then it is imposed on the blood each time the heart contracts. And then that pressure is exerted on blood through the blood vessels. So that's basically how blood pressure works. So in our circulatory system, we have an autonomic nervous system that plays a central role in the heart rate, blood pressure, and other involuntary physiological processes. So this autonomic nervous system is very important, and it has two main parts, which is the parasympathetic nervous system, the sympathetic nervous system. So the parasympathetic nervous system is a system that works when a person is at rest, such as when you are seated, when the heart rate is normal, and you do not need any extra glucose or any other extra thing for the body to operate. So that's how the parasympathetic nervous system works. Then the sympathetic nervous system is a system that is associated with fight or flight. So this is a system that comes into play when a person is under stress. For example, a dog barking at him. So the first instant reaction that you get when you're scared of dogs, if you're scared of dogs, is to run. So the sympathetic nervous system will increase the heart rate to constrict the blood vessels so that the blood pressure can increase, and then there will be more glucose conversion and other things. So that's how the sympathetic nervous system works. So those are the two systems associated. So problem with this system, which is the autonomic nervous system, such as increased activity of the sympathetic nervous system. So this increased activity simply means stress of the sympathetic nervous system will result in an increase in heart rate and vasoconstriction. So when there's an increase in the heart rate and vasoconstriction, there will be increase in the peripheral resistance, meaning the blood vessels will constrict, and eventually the blood pressure will rise. So that's how the blood pressure increases. So due to the increase in the peripheral resistance and blood pressure, there will be reduced blood going to the kidneys, which will result in involvement of the renin, angiotensin, the aldosterone system. So here, we're simply saying, because there is an increase in blood pressure, there will be reduced blood going to the kidneys. And then when there's reduced blood going to the kidneys, there will be a system that will notice that there is reduced blood coming to the system, to the kidneys, which is the renin, angiotensin, aldosterone system. So this system will sense that there is reduced blood coming to the kidneys. So the renin, angiotensin, aldosterone, the renin, angiotensin, aldosterone system helps in maintaining the extracellular fluid volume and arterial constriction. Like I said, this system is responsible for maintaining the amount of fluid that is in the body. And how does it do this? By sensing the amount of fluid that is in the heart. So when it senses that there's reduced blood, there's reduced extracellular fluid, which is basically blood, it will activate some hormones, and there will be more reabsorption of water, and there will be vasoconstriction. So this is how this system works. So now we go into details about the system. So renin is a circulating enzyme that helps in breakdown of angiotensin, which secretes angiotensin 1. Angiotensin 1 is converted to angiotensin 2 by angiotensin converting enzyme. Then angiotensin 2 is a vasoconstrictor of all blood vessels. It constricts the blood vessels and thereby raises the peripheral resistance, raises the peripheral resistance, and so elevates blood pressure. So remember, we said this system we are calling the renin, angiotensin, aldosterone system is the one that maintains extracellular fluids. So when it senses, when blood goes to the kidneys and the kidneys sense that there is less fluid in the body, it will activate that system. And when that system is activated, renin will help in the breakdown of angiotensinogen. So angiotensinogen will release angiotensin 1. Angiotensin 1 will be converted to angiotensin 2. Angiotensin 2 is a vasoconstrictor, which will help in blood vessels constricting. So when blood vessels constrict, this simply means the blood vessels have narrowed and blood will be passing through with increased blood pressure. So that's basically the first part of angiotensin, the first function. Then the second function, it acts on the adrenal gland to release aldosterone, which stimulates the kidneys to increase reabsorption of salts and water, and the stimulation of ADH, which is antidiuretic hormone, leading to raised blood volume and raised blood pressure. So here it will now stimulate the kidneys to release aldosterone. So, or the adrenal gland. So it acts on the adrenal glands to release aldosterone. This aldosterone will stimulate the kidneys to increase reabsorption of water and salts in the renal tubules, and also stimulate the release of ADH by the pituitary gland to increase more reabsorption of water, because the kidneys have sensed that there is less water. There is less extracellular fluid. So they will demand for more reabsorption of water that will result into an increase in blood volume and an increase in the blood pressure. So that is basically the pathophysiology of hypertension. So we have come to the end of our lesson. So just a quick summary here. This is the system, the renin, angiotensin, aldosterone system that is very cardinal in the pathophysiology of hypertension. So you have to understand that angiotensinogen, angiotensin 1, angiotensin 2, these are the three most cardinal things that we have to understand if we are to understand the whole pathophysiology of hypertension. So we have come to the end of our lesson. I would love it if you comment and send the questions to the comments and the contributions and how and where we can correct. Thank you. Subscribe to our YouTube channel. See you next time.